all about calculating surface areas of different three-dimensional shapes. Understanding how to calculate the surface area of a prism is foundational for understanding how to calculate the surface area of all the other shapes we're going to talk about during the rest of the week. First off, let's review what a prism is. A prism is a polyhedron with two congruent parallel faces or bases. So as long as you have a figure where all the sides are polygons, making a polyhedron, and you've got two bases that are parallel and equal, like these two rectangles, it's a prism of some kind. It doesn't necessarily have to be rectangular shaped bases, they just have to be congruent parallel shapes. Surface area really just means the total area of all the surfaces or faces of an object added up together. You could think of surface area as how much wrapping paper it takes to cover the outside of an object. One term you're going to hear off and on is the term lateral area. Lateral area really just means the area around the middle of a shape that's not the bases. So one way people talk about surface area is they'll talk about it being the combination of the area of the bases added up with a lateral area around the middle. One way to calculate surface area. So if we draw a net, you have one on your paper, use the first of the two nets. Let's break it down. So the height of your prism is 10. So this edge, that would be the height of the prism, that would be a 10. And then you could say, well, if this edge is 5 and this edge is 4, then when I draw my net, it would be an alternating 5, 4, 5, 4 sequence around those edges at the base. Now, because each face is a rectangle, you could calculate the area of each rectangle by doing base times height for each rectangle. Like base is 5, height is 10, 5 times 10 is 50, 4 times 10 is 40, and so on. Now, when you get to calculating the area of these rectangles that kind of stick out, I want to point out something important. If this edge is 4, then this edge would also have to be 4 so that when you fold the net together, they meet and create a corner at the same place. So when you find the area of this rectangle, it's 4 times 5. So what I want you to do is inside each rectangle, write down the area you calculated for each one. The 5 times 10 got you 50, the 4 times 10 got you 40, the 5 times 4 got you 20, so on. So to find the total surface area of the prism, I would just add up the area of all those surfaces. And the total surface area is 220 square centimeters. Notice how because it's surface area, the units are squared, as they always are with area. Now, here's a little bit of a shortcut that will help explain how they created the formula way of solving for surface area. With the second net on your paper, I want you to, instead of breaking it down into 1, 2, 3, 4, 5, 6 little rectangles, you're going to notice how you could have grouped some of those rectangles and broken it down into 3 rectangles. The 2 base rectangles from the top and bottom of the shape, and then 1 combined rectangle for those 4 pieces, because they all have the same height. Now for this combined rectangle, when you're doing base times height, the base of that rectangle is 5 plus 4 plus 5 plus 4, 18. Base times height, 18 times 10, 180. Notice how breaking it down differently gets you the exact same answer. Now, knowing the second way to break down the net into fewer pieces is really important because it gives you a visual explanation for how they invented the formula shortcut for creating, finding surface area of a prism. I want you to notice first how really when we're adding up the pieces, it was 2 of the base areas, the top and the bottom, that were both 20s, 2 bases, and then a combined lateral area of the area of the 4 pieces of the middle. Notice how to get the combined lateral area, it really was the 5 plus 4 plus 5 plus 4. That really was the same thing as perimeter of one of these bases, and then times by the height of the whole prism, perimeter times height. And that's really how they invented this formula. Surface area equals perimeter times height of the prism plus the area of two bases. Write down these steps, and then we'll go through the first question together. Step 1 and 2 are to calculate the area and perimeter of the base. So what I always do when I'm solving this on paper, as some of you are writing this out on your iPad, is I always highlight one of the bases. It could be the top or bottom of the base, it doesn't really matter. I highlight one of the bases, so do that on your iPad or on your paper. And then I'll copy that base shape on the side. So the base has a width of 6 and a height of 3. And then steps 1 and 2 are to calculate the area of that base and the perimeter of that base. So I'll make a note, I need the area of the base. Remember, capital B stands for area of the base. And P for perimeter of the same base. So it's a rectangle, so area of base is just base edge times height edge, 6 times 3. And perimeter is just adding up all the edges to create a fence around the shape. 6 plus 3 plus 6 plus 3. This is a coincidence that it turned out to be the same number. That's actually pretty rare. But now that I have the area of the base and the perimeter, I'm ready for step 3, plugging that in to my surface area formula. Surface area equals perimeter, which is 18, times height of the whole prism, not height of the base, height of the whole prism, the 4, the one number we haven't used yet, plus the area of two bases, which is also 18. Because it's an area problem, it's units squared, 108 centimeters squared. We'll go through one more together. First, highlight the base and copy it on the side. Take a moment to calculate the area of the base, capital B, and write that down, and to calculate the perimeter of that base and write that down. All right, so let's check your work. The area of the base, because it's a rectangle, is just the base edge times the height edge, 3 times 4 is 12. Perimeter, 3 plus 4 plus 3 plus 4 would be 14. And then the height of the prism that you'd plug into your surface area formula would be 6, the one number you haven't used yet in the picture. So when you plug that in, perimeter times height plus 2 times b, you get 14 times 6 plus 2 times 12, 108 feet squared. Oh, what a coincidence. That's actually the same answer you got for the last problem, and I want to point out why. Because really, this is just the same rectangular prism, but on its sides. See how the edges are 3, 4, and 6? Just like the edges on this one were 3, 4, and 6. So the point I want to make here is that with rectangular prisms are unique among the prisms because really any two pair of opposite sides could work as bases. You could use the 3 by 6 side as a base, or you could look at sideways and use a 4 by 3 side as a base. You'll get the same answer. Pause here and try question 3 on your own. So first you highlighted the base, and then you drew it separately on the side. You calculated the base area and the perimeter, and you plugged that all in. You should get 64 square inches. Now, sometimes you have a prism where the base shape isn't a rectangle or square. It's something else like a triangle. Notice how here that the only two sides that could be bases are the two triangle sides because they're the only sides that are parallel and equal. Maybe some of these rectangular sides around the lateral area might be equal to each other, but none of them are parallel to each other. So highlight one of the triangles. It could be the front one or the back one. It doesn't really matter. That is your base. And then copy the shape on the side. Now for triangle area is 1/2 base times height. So you do 1/2 base edge times height edge. And then the perimeter is still adding up the outside, so 5 plus 5 plus 8. So 1/2 base times height, some people write it as base times height divided by 2. It means the same thing. So the area of the base should be 12. If you got 24, you just forgot to half it because it's a triangle. And then perimeter is just adding up all the outside edges, figuring out how long the fence would be that would go around the outside of your shape. 5 plus 5 plus 8. So you have the area of the base and the perimeter. From this point out, it's exactly like what you did for rectangular prisms. You just plug it into the same surface area formula because surface area will still be perimeter of the base times height of the prism. But because this prism is on its side, the 12 is the height. It's the one number you haven't used yet. You could think of the height as really just the distance between the two bases. And so perimeter times height plus 2 triangle bases, 240 square inches. So we'll walk through one more triangle, one together. Highlight the base and draw it flat. Notice how it's a right triangle. Because it's a right triangle, then the side actually works as a height. So when you do 1/2 base times height, you get 1/2 12 times 10. So calculating the area of the base, capital B, should get you 60. But then you try to calculate perimeter and you have a problem. You have no idea what the third edge of your base shape is. Oh no, what shall you do? Luckily, you know a trick for calculating a third edge on a right triangle. Pythagorean theorem! Yay! It never goes away. So remember, the C is the hypotenuse. So you could call the missing edge X and plug in 12 and 10 for A and B. And you could round to the 10th place. So the missing edge is about 15.6. So now when you find the perimeter, it's 12 plus 10 plus 15.6. It's around 37.6 for the perimeter. Now that you have area of the base and perimeter, now you can plug it into your surface area formula. Pause here and try the next one on your own. The base is a triangle, so you're doing 1/2 base times height, or you could say that's base times height divided by 2. Either way, you get the same answer. Capital B is 6.3. Oh no, we're missing an edge. But you know what to do. You use Pythagorean theorem. So the missing edge is around 5.2. Plug that in. Your perimeter is around 12.4. Now that you have the area of the base and the perimeter, plug that into your surface area formula, and you get around 124.2 square centimeters. So at this point, you know how to calculate the surface area of rectangular prisms, where the bases are rectangles, triangular prisms, where the bases are triangles, but really those bases could be any polygon shape, including hexagons. So we'll walk through this last one together. Here we have a prism where the bases are regular hexagons, so highlight one of the bases, and then copy that base shape on the side. Because it's a regular polygon, you know your formula for area is 1/2 AP, where A is the apothem and B is the perimeter. Since you need perimeter for this, you might actually want to start by calculating perimeter before really getting into area of the base, because now you know perimeter, you could plug that in for P into the 1/2 AP, or some people write it A times P divided by 2 means the same thing. The apothem is 5.2. Plug that all in. And now you have all the ingredients you need to plug in for surface area. So really the only difference was needing to use 1/2 AP to calculate area of the base. Everything else was pretty identical to the other prisms. Plug into surface area equals perimeter times height plus 2b. And you get around 619.2 square centimeters. Great job, everybody. Don't forget to turn in a picture of your notes on Schoology when you're done.